So guys, the method one that we did, let's get a quick recap of how we derived it. So first, if suppose a quadratic polynomial x minus 1 x plus 7 is given, so first we will plot it on the number line, guys. So we plotted uh, uh, x minus 1. So x minus 1 we equated it to 0 and we got x equals to 1. So we plotted x equals to 1 first and then plus minus we did. Okay, so we plotted this x minus 1 linear factor followed by the next linear factor, which was x plus 7. X plus 7 was equated to 0 and x plus 7 gave minus 7. So minus 7, again plus minus we plotted. Now from 1 we dropped perpendicular. Okay, from minus 7 also we dropped perpendicular. So we saw that 1 on the left hand side all the points was negative, gave negative sign to x minus 1. So here also it was negative. So minus 7 on the left side of minus 7 it was negative, on the right side it was positive. Even after 1 also it will be positive. The same for here also, that even after minus 7 on lesser than minus 7 it was negative. So we plotted my x minus 1 x plus 7, these two linear factors separately on the number line, and when you multiply both of them, x plus 1 x minus 1 is multiplied to x minus 7. Okay, then what happened is the multiplication of the signs of the two linear factors, minus into minus. Here it was minus, here it was minus, so minus minus got multiplied and we got plus. Okay, similarly here it was minus, here it was plus, so here again it was minus into plus, we got minus. Here it was plus, above also it was plus, so plus into plus we got plus sign. So we concluded that for the quadratic factors containing two linear factor x plus 7 x minus 1 in multiplication, the sign of that quadratic expression was plus minus plus with respect to the two linear factors, where minus 7 and 1 happens to be the roots of the quadratic equation. Quadratic equation is when we equate them to 0, right? So in the similar way, we took another example, 3x minus 1 2x minus 17, and we in the similar way we calculated, and again the same signs we got, plus minus plus. It should be noted here that the coefficient of x in both the examples were positive, and in the second example they were 2 and 3, so both were positive. So we generalized it for x minus alpha x minus beta. Okay, plus minus plus would be the same when alpha is lesser than beta. So x minus alpha x minus beta, the formula for this is x less than alpha or x greater than beta. And when we used equality here also, we used equality, or equivalently x belongs to minus infinity to alpha, close interval union beta to infinity. Okay, so that way we did this. Now this was the method 1. Okay, and in the similar way, for lesser than equal to 0, we took this interval from alpha to beta, which we wrote as x greater than equal to alpha, less than equal to beta, or x belongs to close interval alpha comma beta. Okay, so we did one example followed by that. Now the second method that we are going to discuss is method number 2 to derive this quadratic formula that we derived from method 1. Concept of sign is quite simple method. This actually we used in method 1 as well. It was plus into minus, minus into plus, negative, here also negative. For example, if 2 is multiplied to minus 3, what we will get? We will get minus 6, which is negative. Similarly, minus 1 by 5 is multiplied to 4, again it is negative. Similarly, this is less than sign, guys. Now plus into plus is what, guys? Yes, it is positive. Minus into minus again is what? Yes, it is positive. Like 2 into 7 is 14, which is positive. Okay, minus 1 into minus 5 is 5, which is positive. We will use the concept of sign for method number 2 to derive the formula of quadratic formula for what? Quadratic inequality result. Okay, so now again quadratic inequality, where we will derive the results using method 2. So for that again I will take an example and I will uh, generalize it. But the concept behind method 2, using the underlying principles, underlying concept is definitely the concept of sign. What it is this. Like for example, if I want to derive x minus 2, x plus 7 greater than 0. So what we will see here, that this is positive only when both the factors are positive, or both the factors are negative, because positive positive is positive. This is what the question is asking for, and negative is into negative is also positive. So this is what I call case 1. This I call case 2. As you can see here, or means union. So whatever the result that we obtain from case 1 and case 2, we will take what? We will take the union of the two cases. Now within the case 1, when we solve the first inequality and the second inequality, that will impose both should be positive. So in while solving the first inequality, first case, we will use and. Similarly, for the second case, when the two inequalities must be constrained as minus and minus, so minus into minus means the both should be and. These two inequalities we will use and. So to solve each case we will use and after solving case 1 and case 2, we will take the union and it will give our final answer. That is the concept behind method number 2. Okay, so x minus 2, x plus 7 greater than 0, we will solve by method case 1 and case 2. Okay, so this question, x minus 2 into x plus 7 greater than 0, we will solve case 1 when both are positive. So plus plus gives positive, so which means that x minus 2 must be positive, which gives x greater than 2, which can be plotted on the number line as 2, and all the values on the right side of 2, it is 2 to infinity, guys. And we will apply the condition for x plus 7. It also should be positive. X greater than minus 7 we will get, and again we will plot minus 7, which is on the left side of 2 since it is lesser than 2, and minus 2 to infinity again. Now since we are using and of since we are using AND of these two, so we will, whatever the AND result of these two will give the answer of case 1. So AND, so we'll use AND, which gives us what? So in order to find AND, as you can see, we drop the perpendicular from -7 to 2. There, here in the first inequality, there is nothing. In the first inequality, there is nothing. However, in the second inequality, there is something. So the end result would be nothing. So from -7 to -2, there won't be any answer. Okay. Now, if you see from minus plus 2 to, if you see from +2 to infinity, and here also +2 to infinity, both have the answer common, which is +2 to infinity. So the intersection would be +2 to infinity in this case. Okay. So the answer of case 1 is x greater than 2. Okay. This is answer of case 1. Now for the case 2, what we will impose? Yes, minus into minus. Okay. So for case 2, minus into minus should be positive. So x minus 2 should be negative, and x plus 7 should be negative. X minus 2 less than 0 will give you in the next step x less than 2, and if you plot on the number line, it would be lesser than 2. Okay. So x lesser than 2, it is like this. All the values minus infinity to 2 we will take. Similarly, x plus 7 less than 0 gives x less than -7, and if you plot on the number line, since it is lesser than 7, -7 is lesser than 2, it would be on the left side, so it would be minus infinity to -7. Now we will take again the AND of these two, and now as you can see here, if you take AND of these two, okay, from -2, from +2 to -7, what I mean is this, guys. -7 to, from -7 to 2, there is nothing here. From here, there is something, so there is nothing here. Okay, though there is no answer from -7 to 2. Now from minus infinity to -7, and here also minus infinity to -7, both have common solutions. So the answer in case 2, it would be what? Minus infinity to -7. So answer of case 2, guys, would be what? Case 2 answer would be x less than -7, guys. Okay. So the final answer is what? So the final answer would be the union of what? The case 1 answer and case 2 answer. So case 1 answer, what we got was x greater than 2. Case 2 answer, x less than -7. So final answer is x belongs to, I will write this first, minus infinity to -7, then followed by answer here, union 2 to infinity. So guys, as you can see here, so in this example x minus 2, so in this example guys, x minus 2 x plus 7 greater than 0, what we obtained was it was lesser than minus 7 and greater than 2. So uh, for a generalized uh, quadratic inequality having two factors x minus alpha, x minus beta, alpha is lesser than beta, both are real, so it will be from lesser than alpha and greater than beta, means x lesser than alpha or x greater than beta, or in other words we can say that x belongs to minus infinity to alpha union or beta to infinity. That way we can generalize it. Okay, and in case when there is equality here, like so, like this, when there is equality here, so in the answer this less than also will be replaced by less than equal to, greater than would be replaced by greater than equal to beta. Here dark circle will put at alpha and beta, and as you can note here, we replace the open bracket by the closed bracket, so minus infinity to alpha included, union beta comma infinity guys. So that way we can do it. Let's take one example on this. X is 2x square minus x minus 2 greater than equal to 0. Find x. You can try this. Okay. So if you think about this, I will give you the hint first. The hint to this problem is factorize it using Sridharacharya. Factorize. Okay. And then use the formula that we derived above formula we can use. So factorize using quadratic formula, okay, or using splitting the middle term. Factorize using Sridharacharya or quadratic formula, or factorize using splitting the middle term, and then use the above formula. So let's go to the solution to this. So if you see 2x square minus x minus 2, we cannot factorize it, because if you multiply the coefficient of x square and the constant term 4 cannot be multiplied in such a way to give answer as plus 1 or minus 1. So splitting that middle term is not possible. So what we will do, we will factorize this equation using quadratic formula. Okay, using quadratic formula. What is quadratic formula guys? It is x equals to minus b plus minus under root b square minus 4ac upon 2a. So what is a here? A is 2, b is minus 1, c is again minus 2. C is minus 2. So if you substitute the values of a, b and c, so minus of minus 1, b will substitute, then b square is minus 1 square minus 4ac, a is 2, C is minus 2 upon 2a, a is 2. So the value of x is 1 plus minus under root 1 plus 4 2s are 8 2s are 16 upon 2 2s are 4. So it is 1 plus root 17 by 4 comma 1 minus root 17 by 4. So these are the two values of x. The bigger value would be, let's say this is beta, this is alpha. So this quadratic 2x square minus x minus 2 greater than 0, okay, greater than equal to 0 is factorized as what? It is factorized as 2. I will take out x minus alpha, x minus beta greater than equal to 0. The leading coefficient 2, and if you multiply by 1 by 2 both sides, this will be 2 by 2 greater than equal to 0 by 2. 0 upon 2 is 0. So the multiplication of a positive constant doesn't matter. Okay, so it becomes this only. And x minus alpha, x minus beta greater than equal to 0. From the formula we know that it is x is greater than equal to alpha or x is less than equal to beta. So that is directly the answer we can write. Now we will substitute alpha as what? We assigned alpha as 1 minus root 17 by 4 or x less than equal to 1 plus root 17 by 4, guys. And in interval form we can write it like this: x belongs to minus infinity to 1 minus root 17 by 4 closed interval square bracket union square bracket 1 plus root 17 by 4 to infinity open bracket. So this is the final answer. Okay, guys. Now proceeding with the same concept of sine, in a similar way we can derive x minus alpha, x minus beta less than 0, and it comes out to be the same that we did in method 1. And in a similar way, if you derive it using second method, it comes out to be the same, which is alpha beta plus minus plus minus plus. So alpha to beta it will be, in other words, the answer is x alpha to beta, or else we can equivalently write x belongs to open alpha to open beta. Okay, so x minus alpha, x minus beta less than 0, the answer is x greater than alpha less than beta. Equivalently x belongs to open interval alpha comma beta. Now in case if equality is there here, then equality will be here also, and this square bracket would be replaced, brackets, round brackets would be replaced by close brackets, guys, like this. So let's take another example on this. X square minus 5x less than equal to 1. Find x. So how we will do, guys? So again the hint is same. Factorize using is either splitting the middle term, split the middle term, or using quadratic formula or Sridharacharya formula. Okay, so factorize what x square minus 5x minus 1 less than equal to 0. So you have to factorize this equation in the form of the roots alpha and beta. So roots we can find by, as I said, using uh, either quadratic formula or splitting the middle term. Now this we cannot split the middle term, so we will solve it. So we will solve using quadratic formula. We will solve using quadratic formula the equation x square minus 5x minus 1 equals to 0. So the formula is again the same, minus b plus minus under root b square minus 4ac upon 2a. So where a is the coefficient of x square, b is minus 5, the coefficient of x, the constant term is minus 1, that we will substitute here. Minus of minus 5 plus minus under root b square, which is minus 5 square minus 4 into 1 into minus 1 upon 2 into 1. So using this we will get the two values, 5 plus minus under root 25 plus 4 upon 2, which gives us x equals to 5 plus minus root 29 by 2, which is x equals to 5 minus root 29 by 2, 5 plus root 29 by 2. So the lesser value, we know that we assign them alpha, we assign them beta. So x minus alpha, x minus beta less than equal to 0, we will use, whose answer is x greater than equal to alpha less than equal to beta. So alpha we will substitute as 5 minus root 29 by 2, and beta we will substitute 5 plus root 29 by 2. Equivalently, the answer would be x belongs to 5 minus root 29 by 2 comma 5 plus root 29 by 2. That would be the answer, guys.